So this is the notes from yesterday that I need you to remember. The first of which, when I say yesterday, I mean the last time we met. Want over. Can anybody tell me what the rest of that is? Possible. Very good. And what is that? What you want over what's possible. This is only two words. That's what the definition of what is. Probability. Probability is what you want over what's possible. Technically, it's how many you want out of how many are possible. So if I'm doing a coin, would you agree there's two things that are possible, heads or tails? All right. So we're going to see how good of a guesser you are. Would you agree you're going to have to guess either heads or tails? Right? So you'll have a 1 in 2 chance of getting this right. Because there's one thing you want out of two things possible. So it could be like tails, heads, heads. I'm about to do it 3 times. Or it could be heads, heads, heads. It could be tails, tails, tails. Could be any combo like that. Would you please make one up that you think I'm about to do? I'm going to flip the coin. And there's a 1 in 2 chance you'll guess this one right. And then there's a 1 in 2 chance you'll guess that one right. And there's a 1 in 2 chance you'll guess that one right. And you multiply your chances together and you get 1 in 8 chance. 1 in 8 is not like impossible, but it's not very likely. All right, got your guesses locked in? Just 3 letters. Write it down if you haven't already. Like tails, heads, heads, or something like that. All right, you ready? All right, so when I, in a second, flip the coin and tell you what it is, do you get there's about a 50% chance you're right? Does that make sense? 1 in 2 chance that you're right. So here we go. He already asked me, so he's okay. So here's the first flip, and it is a tails. Who started with tails never fails? Raise your hand if you did. All right, that's about half of you. And that makes sense. As a group, about half of you should be right. Okay, now the second one. Ready? Heads. Who got that one right? Cool. Who has both tails and heads right so far? 1, 2, 3, 4, 5, 6, 7. Now, out of those, actually it was 8 people. I counted wrong. If there's 8 people so far, then how many are likely to get the last one right?
4.
Yeah. So we'll probably have 4 winners. But I don't know. Maybe you guys all guessed the same thing. All right. So here's the last one. And it's a tails. Who had tails, heads, tails?
Oh, that was me.
All right. Keep your hands up. Be honest. Don't no cheating for this. All right. If you had tails, head, tails, keep your hands up. Here's this teeny tiny prize. And who else had it? You had it?
Thanks.
Cool. You had it. Now, if you don't like the flavor I gave you, just come up and trade it later. All right. You can't open it, taste it, and put it back. All right. Now, who won yesterday? Raise your hand if you won yesterday, or last time we met. I forgot to hand these out. I didn't hand them out, did I?
No.
Okay, so here you go. Who else won yesterday? I'm trusting you. Who else won last time we met? You won. Nice catch. Anybody else? Who won the last time? It was that coin game where you take the coins off. All right. So, next, let's talk about area. Go to this page right here. Do you remember these from geometry class? That was only last year.
Yes.
What's the A equals for all of these? Everybody write A equals, because I'm a big proponent of knowing both sides of the equation. A equals, hint, this one has a pi in it. Say it if you know it.
Pi r squared.
Pi r squared is correct. Good. Don't say it, write it for these two now. If you don't memorize well, which I understand, some people just don't. You know, one of the things that's made it worse for you is your cell phone. And it makes sense. If you really want to remember something, you typically just type it in your cell phone? Because then you don't have to memorize it. If you want somebody on your side, Einstein didn't memorize things. One of the smartest humans to ever live, and he didn't memorize things. He said it was a waste of his brain power. Because he'd rather save his brain power for the really complicated problems of life. You guys, and me either, aren't ever going to be thinking about things as complicated as he was. because he was thinking about things that had never been like considered before. He figured out just crazy stuff that nobody had ever thought through all the way. And he came up with these concepts that still today, they figured out he was right about not everything, but almost everything that he had like really deep thoughts about. So my point, you might have forgot these, but I understand. But you got to know them. You know, one of the reasons, it's on your next test. If you don't know how to find base times height, or 1/2 base times height, some people probably just thought it was base times height again. I'm putting a 1/2 in front. Some kids would rather divide by 2. It's the same thing. If you are the kind of kid who doesn't like to memorize those kinds of things, I get it, and Einstein got it, but things like the ACT test, they don't give you a formula sheet. You got to either know these or you don't. And then if you don't know them, you're going to get them wrong. And they're not that hard to memorize. So we also are not going to give these to you on the next test. You either know them or you don't. All right. So actually use the formula then and figure out if the sides are what we say they are here. Actually get the answer. And by the way, for pi, you can use 3.14. And you can totally use the calculator on your iPad. So if the answer is like, I don't know, 7 times 3.14, we'll do it and get the decimal. I'm going to be walking past. I'm going to ask you to show me the decimal on your calculator. Yes, it's to just get some kids in gear because I know it's not that hard to do, but I need you to not just stare at your iPad. Use your calculator and your big brain to write down the decimal answer for all 3 of these. 2 of them are whole numbers, 1's a decimal. I'll pause while you finish that. All right, and I had some people get a different rounded answer, but if yours is close to 28 point, what'd you say again? 27. And some people said 28.3, and some people said this exactly. It's all good. All right, and then Graham, what'd you get for the red triangle?
9.
That is correct. And how about Daniel, the orange?
15.
Yep. All right, now shouldn't we really have units? Yeah, but we're not. We're going to kind of de-emphasize that because this is more about the probability. But otherwise, do you get its units squared? So if this was like meters, it'd be meters squared. All right, let's move on. Then area of desire, does that sound like want?
Yes.
The area of what you want over the possible. It's the same thing. It's just what you want over what's possible. So of course there's kind of more complications because you got to find area, but it's just the area of what you want over the area of what's possible. So let's do what? What do we want? We want to hit the shaded region. That's this. Might be like, but there's no base. But there is. If you think about it, if you look at the drawing, you can see what the base is. So figure out what you want, which is the triangle, over what's possible, which is you're going to hit inside the big shape. It's always the bigger one is always the what's possible. And then put a number here, divide them, get the answer. I'll pause while you give that a shot. It's not 35 on top. It's base times height divided by 2. 1/2 the base times the height. I'll pause while you give that a try. At the top, we have 1/2 times 5 times 7. On the bottom, we have the rectangle, which is 5 times 11. If you did all of that right, you'd have 17.5 divided by 55, and you'll get a decimal. It's important for you to understand what that means. What is 17.5 divided by 55? 0.3181. Is this an okay answer? Yes, it is. And what about 31.8%? Is that a correct answer? Yes, it is. It's just rounded. What about the kid that rounded to 32%? Well, it depends on what they want you to round to. That's rounded, and that's okay. All depends on what they ask you to round to. Do you get that any of these 3 could be correct answers, depending on what they want you to round to? Okay, cool. Now this is important. Would you agree that's about 30%? If I'm going to round to a whole percent, it's about 30%. Then what's the probability of not hitting the rectangle? 70. Get it how if this is 30, then the other 70? Does that make sense to you? Because it's out of 100. Let's say that there was a 20% chance of rain today. Then what's the chance of not rain? 80. You have to add up to 100.
Yeah.
All right, so if I figure out this percent and I realize, oh, that's not what I want the other one. You just take 1 minus that. 1 minus 30%, and it'll give you a 70%. But 1 isn't a percent. You're right, I could change it to 100% minus 30%. So if I say not, you do 1 minus. All right, so the probability that you are going to get hit by a bird at some point in your life, you'll be walking along and the bird will just smack into you, is 1 in 1,000. I am totally making that up. But imagine, there is a chance, right? You're just walking along, bird smacks into you. It's already happened to me. All right, so maybe there's a much higher probability than that. At some point you get smacked by a bird. Well, then what's the probability you're not going to get smacked by the bird? You go 1 minus that. And that would be 999 out of 1,000 that you will not be hit by a bird. Have any of you ever had it where a bird hits the window of your house?
Yeah.
And it goes like dong, and then you look outside and there it is flopping around. It's kind of sad. Sometimes they die from that. Sometimes, like in the case of the one that just happened to me on this weekend, it was getting chased by a hawk. So you can imagine how freaked out the bird was. It was like, this thing's gonna eat me. And it wasn't thinking, real well. And so it just was freaked out and smacked into the window. I actually thought, I'm surprised the hawk didn't just go like, oh, easy food, and grab it and eat it, because it was chasing it. But why do you think the hawk shied away? Maybe it knew there was a window there and it didn't want to hit it, or B, it saw me in the window where the other bird didn't. The hawk saw me in the window and it spooked out. The saddest one that ever comes to my mind when a bird hits the window is one where the hummingbird hits the window, falls to the ground, and my grandpa had told me about how he saw a squirrel. I didn't know squirrels ate meat. They do. A squirrel came out, grabbed the hummingbird, ate the hummingbird. Yes, squirrels actually will eat birds. True story. Okay, you can Google it. Not about my grandpa, but you can Google whether or not squirrels actually will eat birds, and they will. Okay, so anyway, what's the probability I am going to guess heads, tails, heads properly? We just did this one. Who's got a short-term memory? 1/2, 1/2, 1/2, and you multiply them all and you get 1/8. Then what's the probability I am not going to guess right?
7 out of 8.
Yeah, you just go 1 minus that and you get 7 out of 8. Are you getting the whole not thing? All right, let's say I figure out the probability of hitting this little circle right here is 10%. What's the probability that instead you would hit somewhere in the shaded region? 90%. Do you get how that's easy to calculate then? You just find the probability you're going to hit the blue circle here, and then you just do 1 minus that. Do you get that? So what's the probability of hitting the blue circle? Let's do this one. So let's say this is 10 by 5, and let's say that the circle has a radius of literally only 1, radius of 1 inch. Would you please figure out the probability of hitting the circle, and then find the probability of not hitting the circle? And pause while you try that. It's what you want, which is the circle. Eventually it's not that, but to start with, let's find the probability of the circle out of the rectangle. It's what you want over what's possible. What I want is the circle, which is pi r squared, which is pi times 1 squared, which is 1 times pi, which is what? 3.14, good. Out of 50. I'm going to use my calculator. What is 3.14 divided by 50? 0.0628. Would you agree that's about 6.3%? Then what's the probability of not hitting that?
1 minus
1 minus that. Can you do it in your head? 95. Point, can I do it? It's close to 94, but it's a little more than 94. I think it's 95.7. Let me use my calculator. I could be wrong. What is 1 minus 6? No, wait. No, I'm wrong. What is 1 minus 0.63? Dang. I did it wrong. 1 minus 0.063. And I'm going to try one last time. What is 1 minus 0.063? There it is. Oh, I was way off. 0.937. I'm sorry. I was trying to do that in my head. That's going to happen to you, too. So just use your calculator, and it's totally okay. There's a 93.7% chance that you'd land in the striped region. All right. We'll talk more about this after lunch. Okay, we're back from lunch, and I just want to give you the big picture one last time. Everybody find this problem. There's two probabilities. You with me? The probability of this happening, which might be like, I don't know, whatever you want, which is the square, out of what's possible, which is the whole circle. And let's say it comes out to like 3%. Well, then the probability of not hitting the square, which you go 1 minus that, and you get 97%. Okay, so let's actually find the real numbers here. Find the probability of hitting that shaded in square. So if you ever get lost, you just go, okay, what do I want? What's possible? What I want is the square, and that's just an area of 3 times 3. Hopefully you don't need a calculator for that. Daniel, what's the area of what's possible?
Pi radius squared.
And what is the radius?
10.
And what is the radius squared?
100.
Yeah. So now you could do 9 divided by, and do you even need a calculator to do 100 times pi? I don't. Maybe you do. Pi is 3.14. Now I did make a mistake on it earlier today, so I can't be like, it's so easy, because I did screw it up once. I moved the decimal over 1 spot. How many should I moved it? 2 times 100 moves it over 2 spots. So then I can use a calculator for that. What is 9 divided by 314? 0.02866. What are we rounding to, Mr. Server? Well, it doesn't say. So let's round it to about 3%. Oh my gosh. That's kind of what I guessed it was going to be. And then that means what's the probability of not hitting it? 97%. All right. Any questions? All right, then let's get to your homework. There is a worksheet. You are going to skip problems 2 and 4 and 9. Skip 2, 4, and 9. So let's do number 1 together. Finding that worksheet. Once you're started, you're halfway done. I really find that's true. I had a job that I was afraid was going to take me a long time this weekend. I was setting up my electric lawnmower. I've got a lawnmower that is kind of like a Roomba, where it just drives around on the lawn and it mows the lawn. It's pretty cool. I never have to get on a riding lawnmower, or I never have to also, like start my mower and store the gas and all the stuff with gas. There's no gas issues. It's pretty cool. So anyway, I had to set that up, and I was like, oh, it's going to take a long time. But once I started, I got it over with pretty quick. I just had to start it. All right, so let's do number 1 together. Let's talk about that in a minute. First, let's do problem 1. Michaela, would you read me number 1, please? Is a big rectangle or is a small rectangle? What's the dimensions of the big rectangle?
It has a base of 15 and a height of 9.
Thank you. And how about the small one?
Base of 9 and a height of 3.
Awesome. Now, what did they actually ask? Find the probability of what? You must ask a question about it, right? Read the directions.
The shaded region.
Is the shaded the inside the small one? Oh, it's this part then. So what you do first is you find the probability of hitting the small one. But then you go 1 minus that. All right, so let's find the probability of hitting this, which is 27 out of, well, I don't know. What's it out of? What I want to start with is this blue box here, which is 27 out of, help me out, is 100 and something?
135.
Thank you, 135. I do remember that from last hour now. Okay, so there's my probability hitting the box. But you want 1 minus that. So I'd use my calculator. And I would do this first to get the decimal. And then I go 1 minus that. Nolan, did you divide the 27 yet? What'd you get?
0.2.
0.2. Then I go 1 minus 0.2. What's that?
20 or 80.
Yeah. 0.8, which you are correct, is 80%. There's an 80% chance you will hit the stuff that's not in the box. 1 minus. It's like saying, I do not want to hit the box. So when you do not is always this part, the 1 minus. Okay, now, I'm not going to promise they're all like exactly the same and super simple. You'll have to use your brain, but you always are figuring out what you want, the probability of the thing you want to hit, out of what's possible. Or sometimes you do 1 minus that. If you're like, oh, well, I'm actually finding the area of the small thing, then maybe you do 1 minus that. So sometimes 1 minus. That's for not. Okay. That should get you through. If you get stuck, please come up and ask, but this should be a really easy assignment to get going on for this week. That's all I got for you for today.